Today, we're going to nerd out on utility thermal energy networks. They are utility built and maintained neighborhood scale clean heating and cooling systems that connect buildings through a shared network of water pipes that transfer heat in and out of buildings. And they are all the rage in the Northeast right now. While the technology has been around for a while, advocates are increasingly seeing utility thermal energy networks, or UTENs, or maybe UTENs, and especially one type of thermal energy network called networked geothermal, as a way to scale up the climate transition for buildings and turn the shallow earth into a battery that can smooth out peak demand for electricity. While it might be a new concept to utilities, this is not a pipe dream. College campuses have embraced district heating and cooling for a while now, and the nation's first system was recently turned on in Massachusetts. And thanks to the 2022 Utility Thermal Energy Networks and Jobs Act, New York is now advancing 9 pilot projects, with more proposed. Allison of the Building Decarbonization Coalition is nice enough to join us here to explain what's happening with these pilot projects. Allison Considine is a New York-focused organizer and strategist for the Building Decarbonization Coalition. And before that, she worked at Sierra Club's Beyond Coal campaign, blocking new gas-fired power plants, and on building electrification campaigns with the Sierra Club. She has a knack for making the most complicated aspects of building decarb understandable for mere mortals like myself. And she will be putting that skill to good use today. Take it away, Allison.
Thanks, Jack, and hi, everyone. It's great to see some familiar faces and hopefully get to know some new folks in the discussion. Like Jack said, my name's Allison. I'm a senior campaigns and communications manager for the Building Decarb Coalition here in New York. And I lead our statewide campaigns and strategy, work with coalition partners in formations like Renewable Heat Now and the Upgrade New York campaign. And I'm excited to take us through sort of a intro level, what are thermal energy networks, just so we're all talking about the same thing, and then share some updates and details about progress that's being made to pilot these through utilities in New York State. I'm going to try not to use acronyms and jargon, but if I do, please feel free to flag that, and I'll stop and clarify, and I might look to Jack to help monitor the chat while I'm in presentation mode. And yeah, I'll jump right in. So I'm going to share my screen. And go slideshow here. Can everyone see that okay? Great. So the BDC, we really try to work with all stakeholders who are interested in the transition to accelerate the movement of buildings off of fossil fuels and towards 100% clean electricity. So we work with people, policymakers, workers, building industry stakeholders, manufacturers, and environmental groups to build this transition together. So here we go. Okay, so I'm gonna start us off with some really beautiful storytelling slides that were designed by Jessica Agelet with the Alliance for a Green Economy. She did it so well that rather than reinvent the wheel, I'm just gonna borrow her art and her framing. So I'm gonna start us off just very simply with like, what is thermal energy? Focus on the word thermal. We might think about like a thermos or thermal long underwear in the winter. Really anything that relates to temperature. So thermal is about temperature, and thermal energy has to do with energy that is maintaining or changing the temperature within a system. Thermal energy is the energy that can make us, or the buildings we live in, or the systems that serve those buildings, warmer or colder. And mostly in New York, we do this by burning fossil fuels. Fracked gas in people's boilers or furnaces is the main way we heat up buildings. But as we're seeing with climate change, we increasingly need to cool our buildings as well in the summer, and burning fracked gas in a boiler furnace doesn't help with that. And we need something that can basically heat and cool our buildings and keep us warm and cool. So the key to this is transfer. If heating a space is moving heat into it and cooling a space is moving heat out of it, we're trying to figure out how to do that in a zero emissions way. So a couple examples to break it down. If my hands are cold. My friend's hands are warm. And we rub our hands together. My hands are going to get a little bit warmer. Their hands are going to get a little bit cooler. They've transferred some of that heat energy from their hands to mine. Kind of similar on a cold day, if I'm outside shivering and my colleague Kate is outside shivering and we hug, there's less of our bodies exposed to the cold air. We're able to transfer some heat to one another and we're warmer together. So we're heating and cooling. So the question that we're asking with thermal energy networks is, how can buildings hug? And really, thermal energy networks are the hug. Now, we know that they're not actually buildings hugging. Buildings are inanimate objects. But what thermal energy networks do is facilitate that hug by using networks of water-filled pipes to connect buildings to allow heat and cool to transfer between them and for heat pumps to exchange heat with that water-filled network. So the heat pumps allow the buildings to extract heat from the network or reject heat into the network. And by rejecting or extracting that heat to and from the water in the pipes, the buildings are all contributing to the temperature of the water in the pipes and using that water to transfer thermal energy around the system. So without this, if each building is just on its own, when there's excess heat, that's being dumped out into the air and not being captured. This is less energy efficient than moving that heat among different buildings. And just like when two friends hug, less heat is being wasted when we're sharing it amongst each other. So there's a couple of different sources of heating and cooling that we have available in our built environment and our natural environment already. We have spaces that need to be heated, we have spaces that need to be cooled, and we have places that can store heat to allow us to extract or reject heat to it. So thinking about heat sources, these are cooling dominant buildings, things like a data center that needs to keep computers cool year round, or an ice rink, or a grocery store with that refrigerated section. Then we have thermal reservoirs. So the steady temperature of the earth allows us with geothermal boreholes to dump heat into that, extract heat from that, store heat there. Similarly, large bodies of water maintain a fairly constant temperature. And then we've got heat sinks. So if we're able to connect some of our buildings that are cooling dominant and have waste heat, we can transfer that heat for heating our homes or heating greenhouses. And to give kind of another visualization of this, sewer water, for example, would be a source of heat. It maintains a fairly constant warm temperature even throughout the winter. Big lakes like the Great Lakes maintain a fairly constant temperature. And we have a lot of different ways we could leverage that heat in our built environment. So here's sort of a visualization of what we're talking about when we talk about a TEN. So this looks at a neighborhood with multiple thermal energy resources transferring energy through the thermal network. We've got office buildings, a school, apartments, a hospital, and they're sharing energy exchange from heat sources like the subway. Those of us in New York City know it is always really, really hot down there. And using surface water geothermal exchange to balance that system. So why should buildings do this? This might sound cool, but it also sounds like pretty large-scale infrastructure. It's a change from how we normally do things. And I'm going to go through a number of the benefits, but because a lot of us are here, probably because we care about climate change, I'm going to start with climate change and New York State's climate law. So in 2019, the state passed the CLCPA requiring a net zero economy by 2050 in New York State. Buildings are the largest sector source contributor to climate pollution in New York. And we know that the main way buildings need to decarbonize is by electrifying, switching to using heat pumps. So things can't stay the same. We can't kind of continue with business as usual. And this is obviously not, a simple story of how we're going to get there. There's a lot of changes we're going to have to be making to our economy. But I think we'll be better off if we approach it in a managed and phased and planned way that leverages highly efficient technologies like thermal energy networks than if we just kind of approach it scattershot. So to give another kind of instance of the issue we're trying to address here, I'm going to talk about a couple of the challenges of a business as usual approach. So we have a lot of fracked gas infrastructure in our state. The use of fracked gas in buildings accounts for about 25% of our building emissions. gas utilities invest heavily in gas infrastructure, and gas mains are expensive. It costs about $3 to $6 million per mile to repair or replace a gas main in New York. And as more and more people electrify, get heat pumps in their houses, switch out their stove for induction, there's growing competition, which means declining numbers of gas customers who are paying for that expensive infrastructure. And it's lower income ratepayers who are going to bear that burden the most. We know that just swapping out fuels into that system isn't really credible or practical or affordable. And we really need to have a plan now to avoid this sort of accelerating cost crisis. The graphic on the right kind of captures that we have spent $5 billion. And when I say we, gas utility spending ratepayers' money, have spent $5 billion since the passage of the Climate Act in 2019 on repairing and replacing and expanding gas distribution infrastructure. If they continue with business as usual, we're going to be on the hook for a bill of $28 billion by 2043. So we have sort of not just our climate crisis, but this crisis of aging, highly expensive infrastructure, and the question of, are we going to start shrinking that system, and who's going to pay for it? So our current kind of approach to this has been a little bit scattershot. You have, somebody whose boiler dies, and maybe they decide, you know what, I'd like to put in a heat pump. That's great. Maybe their neighbor hears about it, think that sounds cool. They get a heat pump too. Someone else is reading about those IRA rebates. They get a heat pump, and on and on. And we have a neighborhood that's having that increased electrification, decreasing number of gas customers. Problem with that is everybody else's bills are going to go up because they're paying for infrastructure that weaves through this whole neighborhood, even though there's fewer people covering it now. So the alternative approach that we are talking about here and that we've really been pushing at BDC is a neighborhood scale approach. So we've got that same sort of neighborhood, and instead of each house kind of popping on its own timeline with a heat pump, you have the whole neighborhood switch to electrification together, and you use a thermal energy network so that all of those houses are exchanging heat with the network and are connected on a shared loop. So there's a few benefits of that I'm going to highlight, and then we'll get into some more benefits going on. But really, that strategic electrification allows us to avoid that accelerating gas system cost crisis. It enables us to move at a faster pace, a larger scale. It makes for a more equitable transition, so there's no house left behind on this block. And it's a much more energy efficient system. This is sort of another visualization of what a thermal energy network could look like. So we have geothermal boreholes, we have the thermal loop, and we have the other aspects of home electrification at play here. So these homes are weatherized, they have rooftop solar, they have a home battery system. So we're also seeing increased resiliency for folks in neighborhoods that electrify. A few other benefits I want to talk about are I'm going to start with the energy efficiency aspect. So this chart shows the current US seasonal electric peaks for buildings. As you can see, we have a summer peaking system. When everybody's running their AC units in the summer, it's really hot. That's when the strain on our grid is the highest, when we have to be producing the most electricity. This next graph shows future seasonal electric peaks as we electrify. So what we can see here is something that's been called the falcon curve, because it kind of looks like a bird of prey. But basically how we electrify matters. So any way we're electrifying, we're going to be more efficient than burning fossil fuels. So I just want to set that as a baseline, is either way we're moving towards more energy efficiency, but it's by degrees. So electric baseboard heating, not super energy efficient. You're looking at really, really high strain and demand on the grid in January and going up again in December. If we use all air source heat pumps, which again are like 2 to 3 times more efficient than a fossil fuel system or an AC unit, you're still seeing pretty high peaks in the winter. Ground source heat pumps are even more efficient, and then networked geothermal systems, which is a type of thermal energy network that uses geothermal boreholes. We're seeing that falcon curve start to land a little bit and flatten out. So this is going to allow us to reduce the amount of renewable energy we need to build out. It's going to allow us to save some money on transmission costs and storage, all of which we're still going to need a lot more of as we electrify our entire economy. But we have a really steep road to climb to hit, a totally decarbonized economy, and making that road a little bit smoother on the building side is going to make a big difference. So another benefit I want to talk about is workforce transition. This is a highly unionized workforce that works on the current gas distribution system. And the same utilities and workers who build gas distribution types today are well suited to build thermal energy networks. It's a similar skill set, similar transfer. They have apprenticeship and training programs. So this kind of creates that pathway to leverage the highly skilled union workforce that's currently keeping us warm and safe in our homes and have them be part of building this decarbonized future. And then I talked a little bit earlier about avoiding gas system infrastructure replacement costs, which could end up sticking us with a multi-billion-dollar price tag. So I'm going to move from sort of what are thermal networks into what BDC is doing in New York to try to drive this forward. Just at a high level, our vision is really advocating together on shared solutions and common ground for this neighborhood scale transition, and really centering a just transition for the union workforce and for communities as we meet our New York climate mandates. So we are part of a collaborative called Upgrade New York. In addition to BDC, we work with the New York State AFL-CIO, the Building and Construction Trades Council, the New York League of Conservation Voters, We Act for Environmental Justice, the Sierra Club, the Alliance for Greater New York, and the Alliance for a Green Economy. And these groups really came together in 2022 around the potential of utility thermal energy networks as that piece of common ground kind of solution. So this is sort of an unusual coalition. We had some backing from the utilities, and we worked together in 2022 to pass this law called the Utility Thermal Energy Network and Jobs Act. It passed the New York State Senate and Assembly with really strong bipartisan support, and it provided a pathway for gas utilities and the building trades workforce to bring their craft, bring their expertise to the work of decarbonizing New York's buildings, and creates an opportunity to invest in disadvantaged communities and bring members of those communities into that union workforce. So the UTENs legislation, UTENs is going to be my little shorthand, so I don't have to say that and spend 30 seconds every time. Authorized each of the 7 investor-owned utilities in New York to develop up to 5 pilot thermal energy network projects. It required that at least 1 pilot be in a New York State designated disadvantaged community, and if they proposed 4 pilots, at least half had to be in a DAC. It directed the PSC to initiate proceedings and promulgate rules for this new utility model. And it required labor standards to ensure prevailing wage and pre-apprenticeship programs are used in building out these pilot projects, and to prioritize transitioning utility workers who are at risk of losing their jobs in this transition. So in addition to implementation of the Utility Thermal Energy Network and Jobs Act, our coalition is also looking at how can we advance projects now on state facilities and campuses. But that is for another presentation. I'm going to keep focusing on the UTEN pilots. And what I have here, I'm actually going to see if I can open up this website to show you how this works. But this is sort of a map of where the current proposed pilots are. I thought I had the link in there. Well, I'll pull that up in a second. But basically, you can go to this at upgradeny.org about thermal energy networks in New York. And as you can see, they're all over the state in the different utility service territories. If you click on these little yellow dots, you can see a short sort of summary of what it is. And we linked to the Public Service Commission docket on that website, where you can explore if you want to get really into the weeds of what are they proposing for these different pilots. You can see those filings in that PSC docket. In the interest of time, I'm not going to talk through all 9 proposed pilots, but I am going to highlight a couple downstate, a couple upstate, and talk about the process the PSC is setting up. So I'm going to focus on Con Ed's pilots downstate. They have 1 proposed for Mount Vernon. This is proposed for a neighborhood that's been designated a disadvantaged community in Mount Vernon. And it would link up to 76 buildings, including residential churches, a fire station, medical offices, a rec center, on 2 connected district geothermal loops with 130 boreholes. This project would allow the retirement of up to a 500-foot section of leak-prone gas pipe. So this is sort of that avoided gas utility investment piece that I was talking about in action. Another proposed pilot they have is in Chelsea. This one would connect a data center that generates a lot of waste heat, like I was talking about, with 4 NYCHA residential buildings, and it's designed to connect to some new residential buildings that are going up from the New York City Housing Authority. And the proximity to additional thermal resources like the Hudson River would allow this pilot to eventually expand if we create the model for sort of thermal utilities to decarbonize whole neighborhoods going forward. And then their third pilot is looking at Rockefeller Center and using waste heat from the Rockefeller Center central plant with a variety of different waste heat systems to connect 3 large commercial office buildings, and using water source heat pumps for that building heating. They're also looking at how they can create a marketplace for waste heat between large building owners with this one. So as you can see, these pilots are in very different topologies. We're looking to learn different things from them. We're very much in that sort of creative pilot phase for utility thermal energy networks in New York. To head upstate, I'm going to highlight 2 of the proposed pilots from National Grid. One is in Troy, New York, and it connects 9 mixed-use commercial and multifamily buildings in downtown Troy. Again, this is in a CAC designated disadvantaged community. It would use a geothermal bore field as that heat source. And what's interesting about this one is they're experimenting with different ownership models. So the the city of Troy would own the thermal generation equipment and associated piping, and National Grid would own the distribution piping, the district loop pumps, and the emergency backup generation. So some of these other models, the utilities owning all of that equipment. In this one, they're kind of looking at joint municipal ownership. And then in Syracuse, they've proposed a wastewater heat transfer system, leveraging all the waste heat generated by the Metro wastewater treatment plant in Syracuse's Inner Harbor, and connecting that heat in a loop with some new construction that's going to be going up in the Inner Harbor, a mix of primarily commercial buildings. And this is going to allow them to avoid building out gas mains into that new development area. So there's other projects. You can explore them a little bit more, like I was saying, on this map on our Upgrade NY website. But I just want to talk a little bit about the process that the state has laid out. So the Public Service Commission is taking a really thoughtful, phased approach to the ultimate approval of these pilots. A number of them that I've been talking about, these sort of like 9 projects I'm focusing on, have moved on from stage 1, advanced into stage 2. And we're expecting to see some progress in that, hopefully by the end of the year. Stage 3 will be customer enrollment and pilot project construction. The utilities are going to have to develop customer protection plans, make sure the folks who are going to be affected by this are really bought in and understand what's happening. Stage 4 will be pilot project operation and management. And then stage 5 is where they'll really pull all of those learnings from these pilots. So as you can see, this is not sort of this new utility model going for prime time. This is the state sort of learning from these pilots as they start to build out these regulations, as they figure out how do we do rate design for these things? How do we create a waste heat marketplace? So there's going to be a lot of learnings, and I know there's a lot of like cross-state collaboration with pilots like the Framingham one that Jack mentioned in Massachusetts. So I have a couple of links here that I can maybe drop in the chat once we move into discussion. But yeah, that's sort of my high level overview of what is up with utility thermal energy networks in New York. And I'm really looking forward to the discussion.
Awesome. Thank you. I'm going to stop the recording now.